Today's lesson is Investigation 6. It's collecting, displaying, and interpreting data. So if you've heard of the study of statistics, we're going to look at how statisticians or people that report statistics and calculate statistics gather data, analyze data, and report data using the different methods of statistics. So a couple of vocabulary words is population. That's a group of people that we want to study. A sample would be just a portion of the population. And then a bias is when a part of the population might be prejudiced towards a certain outcome of a survey or an outcome or an opinion. So let's take a look at a theme park. Say Disneyland, for example. They're building a new restaurant and they want to find out what the population is most likely to desire as far as a food type. So maybe they want Italian food, maybe they want American food, maybe they want fast food, or maybe a sit-down restaurant. So you would take a survey and try to find out what the attendees at the park are interested in. So here's my question for what the class, what we could discuss is, what are the difficulties of surveying the entire population at Disneyland? And if we conducted the survey only among people in one of the other restaurants, how would that change the results of our survey? So one of the things that we've discussed in the past with this question, the first question is, maybe there's like 10,000 people that attend Disneyland in a day. And it's not really possible or realistic to survey all 10,000. So then if you narrow down who you're surveying, if you only survey the people that maybe go to restaurants, if you go inside a certain restaurant and say, what's your favorite type of restaurant, you're going to see a bias because they're in the type of restaurant that most likely is their favorite. So you would, and if you only surveyed the people in the Italian restaurant and then maybe the American restaurant, how would you get the people that are not in restaurants to find out that they have a preference towards some different type of restaurant? So that's to discuss is how do you get an unbiased sample to conduct a survey? And some students have said that the way they do that is maybe stand at the entrance of the park and every 10th customer that comes in or every 100th customer that comes in, you do a random survey for that person. So then it's not dependent upon where they've already chosen to eat, and it's not dependent on age or gender or nationality, but it's very unbiased, so you get a good random sample. So let's say we did conduct a survey, and we gathered the data, and we would do this with a frequency table. So we would take tally marks, so maybe we had 6 people like Mexican, 3 American, and maybe 5 people for Italian. We would say, hey, I've got 6 that like Mexican, 3 for American, and 5 for Italian. And then we could do a bar graph. Okay. So for a bar graph, bar graphs are categorical data. In other words, these 3 items, they're unrelated to each other as far as we can't numerically list them least to greatest or lowest to highest. They're just separate categories, so that's why it's appropriate to use a bar graph. So we could say Mexican would be our first one. There's a frequency of 6, and that's our highest. So I'm going to go 1, 2, 3, 4, 5, 6, and I'm just going to make a bar all the way up to 6 that represents Mexican restaurant, or the preference. And then the American, we could do that next, is a total of 3. So I could show a bar graph like that. An Italian would be 5, and 5 is right about here. And I've always liked to do bar graphs with a number at the top because you can really see just at a glance what the bar graph represents. 5 votes for Italian, 3 votes for American, 6 votes for Mexican. And so that's how to represent that type of data. Okay, there are 2 types of data that we collect and then report it, and we can report it in different ways depending on what type of data it is. For example, the first type is qualitative. Qualitative are things that fall into categories. For example, your favorite color or favorite foods, favorite restaurant. When you display these, it's best to display them as a bar graph because while they belong to the same category, you can't numerically order them least to greatest or greatest to least. They don't have a number to order. So we just make those graphs as distinct, separate bars. They're unconnected. Versus a quantitative graph, this is what you'd use for numerical data. For example, the number of minutes spent doing homework, or the shoe sizes or height. So you would represent those with a histogram where you could set intervals, like this would be 0 to 10, and this would be 10 to 20, and this would be 20 to 30. And then your bars would be connected, and you could see the relationship in a numerical fashion like this. So there's the two types, qualitative and quantitative. So let's take a look at a way to do a histogram, because our data is numerical. We can order at least to greatest. In this case, it's going to be minutes spent doing homework. So if we took a survey and did tally marks on students that spent between 0 and 29 minutes of homework, we could put tally marks and then put the number of students there for frequency. Here's some sample results from the survey, and they have been reported like this. So there was one student that had this much time spent, two students, one student, three students, and two students, and this is what their histogram would look like. So the one student, the number of students here, the number of minutes here, you can see the one student would come up to this bar. The two students that happened between 30 minutes and 1 hour would be shown here, and so forth. So this is a histogram. It looks almost like a bar graph. The difference is they're touching, and the markings below represent a numerical sorting of least to greatest of the values. Okay, so we're going to skip the movie theater survey, and we're going to talk about circle graphs. Circle graphs are a really cool visual way to look to see, like 42% favor this ballot measure A, 18% are undecided, and 40% are opposed. The question is, well, we know that this is 42% based on the voting, okay? 42% of the total number. How do they know how big to draw this angle? So we're going to talk about that. And again, circle graphs, they're appropriate for showing parts of a whole, relative sizes and parts of a whole. So how do we find that angle? You take the percentage and you multiply the fraction or percent by 360. So say you want to represent 40% on a circle graph, you're going to take that and you're going to times it by 360. So really what that is 0.4 times 360. Even better if we went 40 per 100, and we could calculate that out. So we got 40, let's get rid of those zeros. So we really have 4 times 36. Okay, and that is 24, 12, 144 degrees. So if I were going to take my protractor, okay, and if I had a nice handy circle, and I wanted to show, whoops, I lost my center. Let's make sure I got my center in there. Right there. So if I wanted to show 144 degrees, I'm just going to pick a diameter right through the center. Doesn't matter where. I'm going to draw a radius, not a diameter. And then I'm going to measure at 144 degrees. So let's take it, let's go this way. Put that center right there. Line up the dot in the center, and then find 144. Since it's obtuse, I'm going to be following the larger numbers. Here's 140, here's 150. So 145 would be there. Do one tick before the halfway mark, so right to there. I'm going to lift it off, and I simply connect from the center out to the edge. This represents 144 degrees. So that's how I can get my circle graph, or my pie, sometimes they call them pie charts. So say this amount of the population likes this item for your survey. So in our survey for the class, we could do music, sports, service, government, take a tally of how many students in high school want to go into music, go into sports, service, and then how do you figure out the percent though? So if you've got all these tally marks, okay, maybe there's 2 here, 1 here, maybe we have a small class, and this is our total. We've got 5, 2, 1, 3, 6, and 2. That's a total of 7, 8, 11, 17. So there's a total of 19 students surveyed. So we would figure out a percent. It would be 5 out of 19, 2 out of 19, 1 out of 19, 3 out of 19, 6 out of 19. I should have picked a nice round number, but instead of this one. So we would calculate a percentage by dividing. So we're going to do that right here. 5 divided by 19 would be 19 into 5.00. 50 times it'll go twice, that's 38. We subtract, that gives us 12. We bring down a 0. That's going to be about 6 times. 6 times 19 is 54. 6 times 1 is 6 plus 5 is 11. And we get 6. So I'm going to roughly say about 26%. I'm just rounding. 26%. To find our angle measure, we would take 26% and times that by 360 degrees. So again, what we talked about before is turning this into a fraction or a decimal. So let's do this. Let's go 26 per 100, times it by 360. I'm going to get rid of the 0 here. I'm going to get rid of 10 would go in. I could pull a 2 out. So 5 and a 13. So I've got 13 times 36 divided by 5. Oh, should have picked nicer numbers. Let's multiply that out. 18, 7, 0, 9, 3, 8, 6, 4. So 468 divided by 5. 5 into 468. 9, 45, 1, 18, 3, 15, 3. 93.6 degrees. That would be our angle measure for 26%. Let's make sure. 26% is about a quarter of 100%. So is 93 degrees about a quarter of a circle? Yeah, that makes sense. Okay, because a fourth of a circle is going to be 90 degrees. So we are right on the mark. We did pretty good math. So let's use our compass. Or sorry, I always mix these two up. The protractor, and we're going to measure at 93 degrees from this one. So 93 is going to be the bigger obtuse angle, so we're going to go between 90 and 100. Here's 95, 91, 92, 93 is here. Now, this right here is 93.6 degrees. So this would be music in this section. So that's how you can take your data and display it in a circle graph. So hopefully that made sense. And there's some sample from that survey. I think that's all we had today. So remember to do the practice questions in the section for investigation 6.